Thank you very much for coming tonight to our first hands-on of the year. Tonight will be AWS Fargate, and I'm Enzo, your host. As I said, hello everyone, my name is Enzo. A little bit of background on me. I come from Sicily, down South Italy. I came in London 7 years ago, and I started as a Ruby on Rails developer. And for some strange case of life, I started being a Flash developer. Up until I got kind of frustrated with all the technology, and I started getting in touch with DevOps practices and principle. And after that, started working with other big companies and enterprises like Workshare, PlayStation Europe, and Tech Lead in Alfresco. Right now, my role is to be a DevOps CI/CD consultant here in ECS Digital. And if you want to keep in contact, these are my contacts, my GitHub and my Twitter. Right? So, I start from the main topical questions about this. What is Fargate? So, there's been kind of a lot of confusion, especially just after the reInvent, because it was been announced along with Amazon Kubernetes service, EKS. So everyone started to mix them or give more attention to EKS than actually Fargate. And this generated a lot of confusion. I didn't know what it was up until 2 weeks ago. I had a few friends actually tell me what it was. A lot of confusion also around in the office, so I got on me the task to go and research out a little bit. For that, I went to Google, and for Google, Fargate can be either a mall street in Sheffield, a nice video game from 1990s, I remember this, I played this, or is just another orchestration system, maybe a Docker orchestration system, like Kubernetes or Swarm, ECS, or Cattle from Rancher. The fact is, no, not at all. It's nothing of this at all. Fargate goes down the orchestration system, goes before that. It's basically a launch type in AWS. It's a technology that allows you to run containers without managing the underlying instances. Basically, you launch your containers inside this service, but you don't have to manage to create the instances in AWS to host them. AWS will take care of them. This means that it removes the need to interact or think about your servers and cluster. So you don't have to manage them by yourself. You don't need to patch them. You don't need to understand how to take care of them. And finally, this means that you can shift your focus from the infrastructure to the service, which, if you think about it, was the main idea of Docker itself. So take your application, containerize it, and move it anywhere. That was the main point of it. Fargate makes this dream a little bit closer to a possible utopia. Let's just, to give you a better example, let's just imagine your AWS account. We got AWS, we got a VPC into a region. We got a public subnet with connected to the internet via an internet gateway, and a private subnet with a database. So normally, if you're using ECS or using Swarm managed by yourself, you would have to install to create 4 or 5 instances as a cluster, put them doing Raft consensus or them in a Kubernetes cluster, and then install your application on top of it. AWS Fargate takes the instance part away and lets you just deploy the containers or deploy your application as it is. But now only ECS, later maybe EKS. The benefits of this approach, basically, you can see that directly. There is no infrastructure management, no patching, as I said, no scaling, no taking care of your servers so they go down, or auto-scaling groups. It's easy to scale your application. If you just tell ECS, or if you tell Kubernetes to scale to a specific limit, AWS will take care of that. You don't have to think about the underlying infrastructure. And then is automatically integrated with the Elastic Container Services, and in future when will be available to everyone for EKS. Now we are going to make a small demo of all of this, and this is exactly what we're going to do. We have our own AWS account inside a VPC and a public subnet. We're going to deploy a service, in this case Ghost, a blog system, by itself, standalone, and we're going to create a task definition, upload it, and then connect it by itself, without creating any instance on top of it. All right, so if we want, we can actually move to the demo, particular part. That's the short link for the GitHub repository, and then there's the SSH password. Everything is explained inside there. All right. Oh yeah, sorry. Tell me when you are there. Is everyone seeing the GitHub repository? All right. If everyone is okay. Cool. Cool. The repository here is this. Is everyone here? Cool. So let's start from the requirements. So we're going for this session just to use an SSH client, either terminal or PuTTY. Oh, bigger. Can you everyone can see? So for this requirement, we need just an SSH client or terminal or PuTTY. And before we distributed this paper here, this on the left is got the IP of your instance. On the middle, we got the subnet where you're going to launch your blog, and then on the right there is the security group that basically is going to open to the world your blog. To access to your instance, just SSH using as a user EC2 user, and then with the IP that got provided. When prompted, use this password, which is ECS digital, all lowercase. See, check it better. Is everyone inside their instance? Right, cool. Right, we can proceed. I can do that myself. All right, almost there. All right, is everyone in the same state? Cool. The reason why we are provisioning this instance is because so you don't have to install anything by yourself, and this environment has already all the permission that requires for this exercise. It's a little bit better for us to actually just go straight to the point and to not mess around with installing the tools and everything. So what I'm going to do right now is to start the deployment part. To simplify the deployment, I suggest you to define these variables here: cluster name, subnet ID, and ghost SG ID. This will be used later during the exercise. By defining them here and using the data that is in your strip of paper, you can just later just copy and paste the command, and they will work as expected. So I will proceed to do that myself.
The R is missing. The R is
Yeah, I was seeing that. Right. Did everyone put their own subnet ID and ghost SG ID and the cluster name? Cool. We can continue then. Right. As I said before, Fargate by itself is not a technology that is being manipulated directly, but we use it as a launch type by using an orchestration system. In this case, we are going to use ECS. So we're going to go slowly and deploy a very, very simple ECS service. As ECS paradigm commands, the first thing you create is a cluster. Cluster is basically, for people who is not familiar with ECS, is basically a namespace. You can attach EC2 instances to work with it, and it gets basically managed into a single namespace. So to create it, you can actually copy and paste this command. And it will give you this response. In this case, we'll tell you that the status of the cluster is active. You get to see that there are 0 running tasks, 0 pending tasks, the cluster name that we defined here before, and then the IRN, which is the unique Amazon ID that every service, every entity in Amazon has.
I'm voting for a region.
Okay, can you try to do
Are you a root? Any chance?
Sorry?
Are you a root?
Yes.
No, don't be root.
Irregular channels.
Don't be root. That's a bit done only for EC2 user. Normally, I said before, it's done only by EC2 user, and if you cut .aws credentials, you will see that that's been provided with a default region, which is case US East 1. This is also one of the limitations we're going to talk later about Fargate. Right now, it's available only on US East 1, not everywhere else. All right, is everyone at this point? Did everyone create his own cluster? Cool. So The second part is basically creating registering a task definition. Now, for sake of completion, so to not let us mess and waste time, I already provisioned a task definition for you, but I'm going to show you actually what I did. The task definition is a very simple one, and it's basically this. First of all, the family, my blog in this case, will be the service name, or basically the task definition name I was being created. This will be is identification, and later will be also defined like my blog 1, 2, or 3, because you can submit this definition more than once, and it will always have different versions, so you can actually keep a backup copy later. The network mode is AWS VPC. AWS VPC as a network mode is a new network mode made by AWS and disclosed last 14th of November. It basically permits for every container to be attached to an ENI, Elastic Network Interface. So Elastic Network Interface is basically an endpoint, an IP address, both public and private, let's say, simplifying like this. So inside a single, for example, a single instance can be 4 containers, and these 4 containers can have different IP address with 4 different ENI. This is an AWS VPC. After this, we got container definition, name, blog frontend, which is the name of the service later. The image will be Ghost, as I said before, blogging system 120. The port mapping will be 2368 and host port 2368. Now, using Fargate is not possible to change the host port from the container port. Both of them need to be the same. This is because this is a limitation for now of the AWS VPC. And the protocol is TCP. This line here is essential true. This means that this is basically the primary service. And if there were any other service dependent on this, if this goes down, also the other service goes down as well. In every ECS deployment, at least one service definition need to be essential. So in this case, this is the only one. So we're going to do this. Requires compatibilities. This means Fargate. This means that we're going to launch it with only Fargate and not the other one, like the other one being EC2. And then these are the sources for CPU and memory. Any questions about this?
It means that, sorry, it means that they are not doing the bin packing on the underlying instances.
No, you're not doing. You're not even touching the underlying instances. You cannot even get inside the SSH.
Okay, well, just from the AWS perspective, it's like.
From the AWS perspective, basically there was instances with the ECS agent or later the Kubernetes agent automatically, and then we just feed up this task definition or the task later when actually gets in action. Please.
With Elastic Beanstalk, can you define a secret bucket for environment variables?
You can do that. Of course, I'm not covering it here, and there is also a definition here to define an environment variable. I'm just not covering it here for now. Just try to keep it as simple as I can. The task definition is something similar to your own, for example, Docker Compose. It's a little bit more complex than that, has a little bit more limitation, but is more apt to be used into an AWS environment rather than Docker Compose itself. Any other question? Cool. So let's proceed. So as I said before, for sake of simplicity, I already provisioned the task definition in all of the accounts, so you don't have to register it. But if you have to do that, the command to create it is register task definition by inputting a JSON file, in this case. All right, so once the definition has been uploaded, it's time to create a service by using this following command. The service in ECS is basically a controller. It takes care that to scale your own instance to a specific size, It takes care to spawn task action to actually download the image, run the container, and keep it up all the time. And yeah, that's basically it. It's a controller of the task itself. The task is the action. The service is the controller that takes care that the task is going to be executed. By analyzing this command, at the beginning you see that the command itself is create service, and we are feeding up where actually to create the service. In this case, the cluster before cluster name. The service name, it would be Fargate for everyone. That's because I've got a big lack of imagination. Then the task definition will be my blog one, which will be, as I said before, first revision of this task definition. The desired count will be 1. This means that we are asking the service to just create only one service and nothing else. We can do that for 10 or 20. Please don't do that, because the limit, one of the Fargate limitation for now is that there can be only 20 Fargate services running at the same time per account per region. So that will make me a little bit problematic in case since everyone is sharing the same account. The launch type is Fargate. As I said before, we define in the task definition the capabilities to be Fargate, and then now we are actually defining please launch as a Fargate service. And then this is the most important part, the network configuration. So when you create a Fargate service, you don't actually launch it just somewhere else in the AWS environment. You launch it into your own VPC. Basically, you on your own VPC doing your own rule. This goes a little bit tip the scale for the AWS shared responsibility. So for everyone who doesn't know, AWS has got a shared responsibility to secure the cloud along with the customer. So AWS takes care of the physical security of the service, and the customer takes care of the security group, the VPC, application level security. In this case, this tip a little bit more, because now AWS is taking care of also the instances where they're running it, they're going to be safe and sound. So they're going to patch them. There's something similar to RDS, to every managed service, but in this case, they're just going to take care of that. For this reason, Fargate is slightly more costlier than just using normal containerization, but this we can see later. Right, by defining the subnet and defining the security group, we are placing these Fargate instances inside our own security rules and security domain. And one of the most important part here is assign public IP. In this case, we are just assigning a public IP to our instance, so later we can access it. All right, let's see if this works. So you should be able to just copy and paste it. Probably I just Oh, that's interesting. For which subnet ID? 80335 EDD?
Yes.
All right.
Same subnet.
Same subnet.
80335.
Yeah, probably then that one is probably is faulty. All right. Billy, take the other one, please. Can you distribute a different one than 8033 to people who was that?
Good job with 420.
Yeah. Morgan? Need one as well. Yeah. You probably need to exit from your own from your service from your instance and re-enter your own into the new one. Right. All right. A second.
When we have an issue, this is my subnet. When we have an issue, this is my subnet.
Which one?
33A1877.
No, it's not. We'll see, probably.
Yes, it is.
Because we didn't make a sacrifice to the down goals.
Happens. Yeah, I need to create the cluster first. Huh. Oh, right. Right. At least here we did it. Sorry for the inconvenience. So, by creating a service, right? So we did it. By creating a service, we basically add this kind of output. So analyzing this output gives us a little bit more information. One, the fact that the service now is active. The launch type is Fargate, and the network configuration is one we actually defined before. As a subnet, as a security group. The platform version of Fargate will be the ECS will be the latest. The service name is Fargate, as we said before. The deployment itself and all the information is basically a replica of what we saw before. But also the most important part is that the desired count here is 1. And the running counter now is 0 because it's still provisioning. Did everyone arrive to this step? All right. So I can proceed. At any given time, of course, we can get back the information of this service by just using ECS Describe services. Here it back again. Now, if you see here, one of the things actually is missing is that, yeah, I'm going to assign the public IP, but on all of this, where is the public IP? It's not available in the Describe services at all. That's because it's not his responsibility. As I said before, in ECS, there is a division between service and task. The service being the controller, but is the task who actually takes care that the system is up and running, and the one that is the action itself. So to do that, we are going to understand what is actually the public IP. We are going to go through a little bit toward the networking of the AWS networking. So do you remember, said before the definition when we said the AWS VPC? This means that even if the container are attached to some instance that we don't know in the AWS cluster, they have attached an ENI, and that's the best thing. The thing actually, it's why AWS VPC actually exists. In order to retrieve the public IP from this ENI, we need first to find the task ID. To do that, we can describe the service again, but at this time we grab the task. This is the string we need. All task ID in AWS ECS are in this format. Okay? Did everyone arrive to this point? Okay? So, once we have the task ID, we can use a command called AWS ECS Describe Tasks. Copy and paste. Yeah, I'm not a fan of this touch bar here, the new MacBook. Okay, the task is ready here. The command is ready. By this, all the output that comes up, and a lot of output. So we got what actually is happening. Means it's attached. In this case, the network interface is attached. That the status of the container actually is running, and that has its launch type is Fargate. But the most important part is this: the network interface ID is this part. This little string. If you have problem finding it, you can easily repeat a command by grabbing the ENI. And this will be the value that you get back. Once we have that, we can use a specific command called EC2 Describe Network Interface, which will give you all the information that you need on the ENI. All right. Again, a wall of text. But in case we can see that network interface has a public IP, public DNS name, private IP, and private DNS name, exactly like any EC2 instance. And the most important part is the public IP. We can copy, open a new tab on port 2368, because that was the port we found out on the task definition. Let's hope for a while now. And yay, we have a ghost. We did it, yay.
This was kind of good working against beer.
Right there.
Oh, nice. Like beer. 2 beers?
Right, did anyone get access to their own blogging system? Right. About this part, is there any question that you want answered?
You know if there is load balancer integration between Fargate and ELB or ALB?
Yes. So you don't interact Fargate with ELB directly. Fargate by itself is just a launch type. It's just like asking that your EC2 instances are, but just the system itself is behind the load balancer without an application. So in the case of ECS, there is a service load balancer, in which you can attach your services, the one, for example, that we just created, to a load balancer. So if the service, for example, has 10 running instances, you attach them to the service load balancer, and they will be automatically load balanced between all of the containers. Then you can decide which load balancing strategy you can adapt.
How does it work in terms of scaling? Like Fargate, sorry, did I?
No, I was going to say probably it's going to hook with the target group, so the similar way you can probably do it.
I found out that actually I can make an understanding if I would a service as an auto-scaling group, like the concept of auto-scaling group, and the task definition as a launch configuration, right? And then normally for a load balancer, you point the auto-scaling group to which load balancer go, right? Same thing here. You point to a service to which load balancer go. You attach it. It's not the same, of course, but the concept is very similar.
Can you get a public name? Like, can you use route 53?
Of course. You first attach it to load balancer in case you don't want your instance to be public IP. I don't suggest it. And then you attach load 53 to the load balancer. Best result: use CloudFormation, use Terraform, so you have everything in front of you. Easy to be.
Sorry, the thing is for the auto-scaling, because in the case of ECS, you have an instance that runs on.
Yeah.
So you can say, okay, scale, like create 5 containers, and you create the instance below in the cluster.
Yeah.
In this case, how it works the auto-scaling?
In this case, the auto-scaling gets defined into ECS, not into Fargate. So remember at the beginning we said the desired count 1.
Okay, but
then later you can actually change the behavior by hooking it to CloudWatch.
Yeah, but like in the case of ECS, the scaling will actually do you just create new containers that they distribute on your instances.
Yeah.
But it doesn't really auto-scale the instances that are behind.
In this case, still not, because then later the only limitation of Fargate is the limitation of ECS. So basically, if you say the ECS later, if you want dynamic auto-scaling with ECS, you can actually apply to it. The only advantage of Fargate that you don't have to think that to provision or to actually create a new instance. That's the only basically difference.
Yeah, it's simply because as a ECS, you can say, okay, auto-scale to 10 on the background and by a small instance.
Yeah.
The CPU power and RAM is still like, I can create 10 containers or 20.
Okay.
In reality, it's not that I'm really scaling because I hit the limit.
Of course. But I got you back to the task definition before. Tasks. Is in the end, I define the CPU and memory here. So this is basically that every container will access only to, or will have its own access to only to that. So you can really put 10 container with this memory on a single instance, unless the instance has enough memory and CPU for everyone. But in this case, AWS Fargate will take care of that by itself. In case, if I didn't leave you a little bit wanting, we can actually talk about this later in front of a pizza. Not a problem about that. Any other question? Cool. So demo part is basically done. If possible, I really ask you to actually clean up the service you created. To do so, to clean up any service in ECS, the first thing you need to do is update the service itself to have a running count of 0. It will refuse to delete the service if the running count is more than 0. So let's do this. If you see here now that the running count is still 1 because the service is still running for a while, for a couple of minutes, and then the desired count is 0. But now the service can be destroyed, and you can destroy it. You can destroy it by using the command delete service, pointing to the cluster name and the service name. Now, important part for anyone who's interested in knowing more about ECS is that the system, the container is not automatically destroyed. It takes some time to drain all the connections. So the first thing is starting is called draining, and then it will be disabled. Finally, we can delete the cluster. The cluster is not really deleted, it's get inactive. So later can be actually reawakened, well, probably for audit trail or for keeping a record of it. And that's the state. All right, so we did it up until now. It was good. Sorry for the inconvenience with the EC2 instance. I think I tried them, all of them before, but nothing happened. But you may never know what happens with the demo gods. So, as I said before, AWS Fargate right now has few limitations. So it's not for now seeing a lot of use. Some production use as well, not extensive. First of all, it's only available in US East 1. If you know a little bit more, US East 1 is the experimental region. All the new things that from AWS comes first there. And by best practice, is basically never a good idea to host a heavy production system on US East 1. For example, don't know if you remember a few months ago, something happened to S3. S3 went down. All the services in US East 1 went down with it. But of course, since it was just a region, the problem was localized because they were experimenting there. And from there was a big lesson for a lot of companies to not keep their production level in US East 1. So be aware of this. Said before, 20 Fargate launch type task per region per account. You can ask to raise the limit, and we tried, but apparently there is not still the option to ask the specific service to be increased. You have to go through a little bit talking with support many times, and we were short on time, so we did a different thing. 20 public IP address for task using Fargate. This is one of the other services that can be raised. Still, there's a little bit of a wall communication between you and support because this is still not available. And right now, it's working only for ECS. And now, of course, it will be one of the main targets of EKS when it will be available to everyone. And right now, it's only available to few people, just as EKS. So I think it will take some time. It will take some time, probably by the mid-last quarter of 2018, hopefully. Use cases defined was a quick POC. So you don't have time to create your own infrastructure, to create your own Terraform, create CloudFormation to deploy this information. You just take your services and just put them into a Fargate. Done. I want to show my client how the potentiality of AWS. This is a very good position. You containerize their own application and put them on the cloud. Easy. Unexpected scaling scenario. This is the scenario of Monzo. So the main idea of Fargate and DKS was that Monzo needed more power for the transactional engine. So they really didn't know how much traffic they were going to get. So they resorted a very experimental version of Fargate with AKS, and they're using it, and they were super satisfied. Specifically, in case of EKS, because Kubernetes in very large cluster start losing coherence. So you have to coherence between the consensus. So you need to start making some trick to actually refresh the consensus amongst all the clusters. So it gets a little bit tricky on big scale. Operational burst is another case in which you need computational power or operational power to crunch numbers. you don't want to use Hadoop because you're using your own MapReduce system, that's a very good case. And then testing on demand. I just want to quickly spin up an instance, normal instance for UI testing from Jenkins or from Bamboo. I don't need to go and ask EC2 instance to be up to deploy services. I just do one single command and everything is done. Easy. And many more. If you have any other ideas or can be useful, I'd really like to hear. And that concludes this. Thank you very much.